Okay, this is a tutorial on lab number 2, series circuits. So I've set up my breadboard, and I have 5 resistors. I've used different resistor values than what is specified under the lab. I have my battery currently connected to it, but of course I've got these power leads are disconnected, so there's no power going through it. And one of the first things that it asks you to do is to check your resistive values. You should have done this while you were checking, to see, what resistors you need to use. But you can also place them in the board. So, once you've got your values, you can also place them in the board and then read across the resistors like this. So I got 47 there. So I got 100 ohm there. 82 there. 100 there. And 100 there. So again, your resistors will be different based on the lab requirements. So that's the first component, is to check to see your resistive value of the individual resistors. The next thing you want to do is to make sure that your circuit is connected properly. Is you want to check your total resistance and make sure that it adds up to whatever your Ohm's law value of total resistance is that you're expecting, which is going to be the sum of the individual values of resistors. So to make sure that they all equal exactly what it is you're expecting them to equal. Bring that up to the next level so I can see a little bit better. There we go, 429 ohms. Okay, so the next component that it asks you to do is to check the voltage. So first thing we're going to do is we're going to put this to voltage. I know I'm using a 9-volt battery, so I'm going to put this at the 20-volt range. Remember, in DC. And what I'm going to do is I'm going to apply the power to the circuit. So I'm connecting my negative there, connecting my positive there. And it asks you to check the voltage values. So when I'm checking the voltage values, notice how I've got the black over here, and if I go like this, I'm going to get a negative value. So you want to always keep your red lead closest to that red power supply, the positive. So now if I check the voltage here, I got almost 1 volt, 0.97 of a volt. Go to the next one, 2.6 volts. The next one, 1.69 volts. 2.07 and 2.08. Remember that the sum of the individual values of voltage drops through this linear network must equal the total value of voltage applied. So if I was to check to see what my total value of the voltage applied is with this load attached, I can go like that. You can see, okay, I hit 9 volts, 9.01 volts. The next component it asks you to do is to open up the circuit and check to see how much current is running. And it's very important that you follow this method, because you don't want to just check the volt. You don't want to check the amperage like this, because then you're going in parallel with the power supply, and then you're going to blow a fuse that's inside this. So this is very, very, very key. And on the lab, it tells you exactly how to do this. So I'm going to show you. You should have calculated already using Ohm's law what you've determined your total current would be. So you'll know what setting to be on. So I'm going to move this dial. So that's AC amperage. I want to go to DC amperage. So DC amperage, so 10 amps and 200 milliamps. I know I'm going to be under 200 milliamps here. So I'm going to use this setting here. And what we want to do is want to open up the circuit like this. So now I've got the power from the battery. It goes along here, comes out here. What I'm going to do is I'm going to put that into my meter. I'm going to put that into my meter like this, and then I'm going to go back to the circuit here, and I'm going to read my current. So there you go, I've got 20.7 milliamps of current flowing in this circuit. Now it doesn't really make any difference if you go like this with your black there. It's just going to end up with a negative value, and that's just because of the way you biased it. So keep the red on there, bring the black back to there, 20.7. And just to show you, so that's amount of current is a function of how much resistance